Now, all right, we're looking at 6.4, similar triangles. The new thing we're learning today is angle-angle similarity postulate. If two angles of one triangle are congruent to two angles of another triangle, then the two triangles must be similar. Okay? So, the triangles are shown here. We're going to list all the pairs of congruent angles and then write proportionality statements. Okay. So this is easy peasy stuff that we've been doing. I'm going to actually look at B because I think B is a little harder than A. I think we've got this A down. So let's start here. I'm going to look at the inside triangle first. I've got angle T, angle X, and angle Y. What is congruent to angle T? W. What is congruent to angle X? X. Good. What is congruent to angle Y? Z. Good. Okay, now let's make up some proportionality statements. Okay, I'm going to put the little over the big like we've done before. So we've got XY, we've got TX, and we've got TY. Okay. XY is corresponding to what side? XY is corresponding to what side? XZ. Okay, let's look at it. TX TX is corresponding to what? WX, good. Okay, and then we've got TY is corresponding to what? WZ. Okay. So let's make a similarity statement using these. Triangle TXY is similar to what? WXZ. Questions about that? Do you want to try C? Okay, let's look at C. All right. So I'm only given one angle here. How do I know what my other angle is? Because it's angle-angle similarity, right? What do I know about this? What do they have in common? Quentin, your cell phone does not have the answer. So you can put that away. Parallel lines. These are parallel lines. And so parallel lines, and we're cut by a transversal, so that means the alternate interior angles are congruent. So now we have angle-angle similarity. So let's do this. We've got triangle K, triangle L, triangle J. I want to know what they're similar to, what they're congruent to, what angles are congruent to. So what is congruent to K? M. What is congruent to L? J. What you said J? Yeah. What is congruent to J? And I don't mean J here, I mean this J. L, this L. Okay. That one's a little weird because they have those angles in common. Okay. Ladies and gentlemen, we're going to pause for just 1 second. All right, ladies and gentlemen, so let's look at what sides are proportional. Okay, so let's look first at KJ. What side is proportional to KJ? LM. Okay, let's look at what is proportional to KL. JM. And finally, let's look at what's proportional to JL. Or JL?
I mean LM.
JL is proportional to JL. Or is that wrong?
No, that's the LJ.
No,
Yeah. That's correct. It's JL is congruent to LJ.
All right. They're the same thing. If we wrote JL or LJ, I think we'd be okay. But I see what you're saying. You're matching the congruent angles together. Okay, so let's make our proportionality statement. Triangle KLM J is similar to triangle MJL. Okay, can somebody grab the door for me, please? Okay. All right, unfortunately, this is going to disappear because that's the type of computer program I'm using. I apologize for that. Okay. So let's look at example 2. We're going to find the values of x by using this angle-angle similarity. Okay. What would the measure of m be, since these two triangles are similar? X. What do the interior angles of a triangle add up to be? 180. X plus 3x plus 80 equals 180. Okay, I'm going to do two things at once. You ready? X and 3x is 4x. Subtract 180 equals 100. Okay, do two things at once. So x equals 25. All right, let's try another one because that was with angles. We need to do with sides. So we're gonna, if we're dealing with sides, we can't just set things equal to each other, right? We're gonna have to set up what? Portions. Good. Okay. So let's look at this. I'm gonna look at everything and mark stuff that I know. Okay. I want to find x, but it's crazy. X is this little part right up here. X is this little part right up here. Okay? So that's not really part of a triangle. So I'm going to have to do something with that. I know this side right here is proportional to the length of this whole side right here. And I know that 15 is proportional to 20, or is corresponding sides. So I'm going to first say I'm going to do little over big. I'm going to say 15 over 20. And then I'm going to set my proportion. Okay. Well, I know the big triangle's length is what? 17, so I'm going to put that on the bottom because my big number's on the bottom. What am I going to do with that x? How would I find out what this little part is? So, not x minus 17, but 17 minus x. Okay? So we can do one of two things here. First of all, do you want to reduce this so we have smaller numbers? Okay. How many times does 5 go into 15? How many times does 5 go into 20? Okay, equals 17 minus x over 17. I'm going to tell you right now, if you left it 15 over 20 and just cross multiplied, you get the same answer. I just like dealing with smaller numbers. Okay. We're going to work on our cross multiplying skills because that was one of the issues on the quiz. 3 times 17 I'm going to do first. What is 3 times 17? What is it?
51.
Okay, 51. And then we're going to do 4 times 17 times x. So let's write it like this. 4, 17 minus x. This is a big issue that you guys forgot on your quiz. And then if we have the 4 outside the parentheses, we're going to distribute. So we get 51 equals 4 times 17, which is 68, minus 4x, because I distributed. Now I'm going to subtract. I'm going to go 51 minus 68, and I get negative 17 equals negative 4x, and I'm going to divide by a negative 4. Negative divided by a negative is a positive, so x equals 4.25, or 4 1/4. That's it. How do we feel about this? The one with the sides is harder. It's true. Okay. I'm going to move on to example 3. We're going to determine whether the triangles can be proven to be similar. If they are similar, we're going to explain why and then write a similarity statement. If they're not similar, we're going to explain why. Okay. We've got this funky looking kite and we're looking at our two triangles. And we're comparing to see if these two triangles are similar. Okay. Now, it says my two sides are congruent, right? I'm teaching up here, not the back of the room. So. It says that these two sides right here are congruent. What does that mean about the angles? They're congruent. How would I figure out what those angles are? I know these two angles are congruent to each other. So could we make both of them x? So 50 plus 2x would equal what? The interior angles of a triangle are? Okay. So let's solve. 180 minus 50 is 130. 130 divided by 2 gives me 65. So I know both of those angles are 65. What it doesn't tell me is what these angles are. These angles are also congruent because of base angle theorem. They are congruent to each other. So I'm going to do 2y plus 76 equals 180. And I'm going to solve for y. 180 minus 76 gives me 104. Divide by 2. And I get y equals 52. So do I have two angles on both of these triangles that are congruent to each other? Is any of the angles on the blue triangle congruent to any of the angles on the red triangle? No. Not similar. No angles are congruent. How do we feel? Good, bad, okay? Look at the next one. We've got two parallel lines cut by a transversal. So these two angles right here are congruent. Do we have two angles that are congruent to each other for both triangles? Yes. They are similar. I'm going to use this for similar. By angle, angle. So triangle ABD is similar to triangle. What matches A? I'm going to say CBE. Or, yeah, I'll do B. B is good. And what matches B? C. And what matches D? E. We're going to skip the next one because it's the same thing and go down to example 4. Think of the one. There we go. All right. Find the coordinates of E so that OBC is similar to ODE. Okay, so let's make this picture bigger. We're not doing 6.4b today, by the way. Okay, we know that we're right here. O is at 0, 0. We know B is at 0, 4. Who's ever tapping, please stop. C is at 3, 0, and D is at 0, 7. Okay. What is the length from 0 to B? How much did I have to go up? 4. So this length right here is 4. What is the length from 0 or O to D? 7. So this length is 7. Okay. What's the length from 0 to or O to C? 3. And we don't know the length from O to E. So I know if we take little over big, 4 over 7, it needs to equal little over big. Cross multiply. 4x equals 21. X equals 5 point something. What? 0.25. We know my arithmetic is horrible.